So now we're going to find the polar coordinates of each point. Now this is a little bit more difficult because we have to think about where we're actually at on the XY plane, and we'll see why that is in a minute. So first off, I'm just going to plug in. Now keep in mind, this here is my X and my Y. So my X is -3 and my Y is +3. So if we look at the first part here, to find R is going to be simple enough. So I got R squared, and that equals -3 squared plus 3 squared. And that's going to equal, so 9 plus 9 is 18. So then R equals plus or minus the square root of 18, which is really plus or minus 3 square root 2, if I simplified it. All right, now we get this plus or minus here. So this is what I mean. This is the first part of trying to understand where I'm actually at here. Now there's another part to this. So now when I do the next part, now I'm going to do the tan. So now the tan of theta equals y over x. So that's going to be 3 over -3, right? My x and my y. Yeah, make sure I had it right. Which equals -1. So then I have to think about, hey, where is theta equal for, where's the tan of theta equal to -1? What would theta be for this? So then I would have to think about, hey, that means where is, and again, what I would do is I would draw out the unit circle here, and I would say tan is, all students take calc. Tan is negative here, and it's negative here. So I know this is going to be my 1, 1 triangle root 2. So I would say that angle is going to be, what is that angle? 3π4. Or if I take it all the way around, that's going to be 5π4. Is that right? Yes. No. 7π4. Because 8π4 would take me all the way. Okay, cool. All right, so anyways. So now we have these two angles here. So we have 3π4 or 7π4. Now this is where the idea of understanding where it's actually at in the graph comes in handy. Because now if I take that original point, I'm just going to draw this here. And I'm going to say, okay, let's see where this point is. So I go over 3 and I go up 3. And there's where my point is actually going to be for both of these points. So what I'm going to do here is I have to think about that now. That looks like I could use 3π4. And it also looks like I can use the positive 3 square root of 2. So my actual answer for this one then would be, I'll just draw it down below here, 3 square root 2, comma, 3π4. Now looking at it another way, I could also say that if I take the negative 3 square root 2 and I take the 7π4, that would also be an answer to this. Now think about this. I would go down 7π4, that would take me all the way around to there, and it would be in that direction generally, but now I have a negative on the radius there, so it means I would shoot out this way, and it would actually end up being in the same spot. So actually both of those would result in the same answer here. So here I could have two answers. Now in the homework, just be careful because a lot of times they will specify which way to go with these. But there's our answer. We should try another, right? Here we go. All right, I should come up with another one here. So let's try this one. Now again, I'm just going to plug everything in. I'm going to pause it for that so I don't take up too much time on video. So take a look at what we end up with here. So now what I'm going to do is tan inverse both sides. So I'm actually going to get theta equals tan inverse of 2.625, and I'm just going to plug that in my calculator. So I have to be careful of what I have it in. So it looks like I'm going to put these in radians. If you want to do degrees, that's fine, but I'm going to do radians. So I'm going to pause while I do this. So here's what theta equals. Now I'm just going to plug it in for R and get that answer. So this means R equals 2.2472 blah blah blah. Now don't forget, this could be plus or minus. So this is what we need to address now. So for now we're going to just graph this thing and kind of see where it's at, the original point. And this is kind of why we have to do this, so we can pick the right combination of x and y here. Or I should say r and theta. Okay, so anyways, so now first off, the answer I got for theta was 1.2 radians. So that's going to put me about here. Okay, that's about 1.20 blah 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 radians. Okay, and then I have to end up, let's see where we need to end up with this. So that's the first piece of this. So now if I take the negative 0.8, so I'm just going to take my original now, and I'm just going to graph it. So negative 0.8, now I'm going to go 2 for a negative 1. So 0.8 is going to be about here. Okay, and then I'm going to go down. That would be 2 would be down here then, negative 2. So 2.1. So actually, I'm going to be down here somewhere. Let me get rid of that other one. That other one popped in there. I hate when it does that sometimes. So it's going to put me down there somewhere. So now if you think about it, my 1.2 is here. Okay. Now if I'm going to be in the right place, I'm actually going to have to pick the negative one. Okay. So to be down here, it's going to have to be the negative. So if I pick the 1.2 for my theta, I'm going to have to make sure I pick the negative r for my radius. So then my actual ordered pair is going to be that 1.206 blah blah blah. Oops, I messed up. I have to put my radius first. And then for my theta, it's going to be the 1.2068. And that's going to be my r and my theta for this problem. So just keep in mind, when I deal with x and y, I have to understand where it actually is in the rectangular coordinate system to actually put the right combination of r and theta together so I can be in the right quadrant and in the right place.